Okay, let's keep going. All right. Okay, so now I think this might be where we stopped, and we didn't go over the slide. I'll start from here. So really, so as I said, we like to look at populations and samples of people or objects from their corresponding population, and to study them, one can consider using experiments or observational study. Basically, in an observational study, it's really what it sounds like. You're just observing. Sorry, blew my nose. It's just an observational study. In other words, all we're doing is we're just observing what's going on, and we're taking measurements. You are getting data, but you're not giving the members of the population anything. You're not administering anything to them. It's not like in an experiment where you are studying and observing, but you're seeing what the effects of a treatment are, a treatment that you're administering to them. You're trying to see how they react to an outside influence, a treatment, basically. That's what they do when they test medicine, like the COVID vaccine. With vaccines, that they like to test it. They don't want to put something out in the market that's not going to work. They use experiments to see, if it's effective or not. They want to see how people react to that kind of treatment. With an observational study, though, they're not giving them a treatment, but they are, however, observing. Like with medicine, for instance, you would have experiments, that kind of thing. Sometimes you have to do an observational study instead of an experiment for ethical reasons. For instance, if you wanted to learn what effects does smoking have on people, you can't go up to people that are healthy and just tell them to smoke cigarettes. If you want to know what the COVID vaccine does to people, right? They were able to determine what effects it has. They didn't just purposely give people COVID. They observed it, an observational study. So with smoking, they would observe people who have smoked for years or however long, and they would observe what happened to them. What effects does it have? Okay? They wouldn't use an experiment for that. To me, that would be very unethical to get someone sick like that. So sometimes they have to do an observational study instead of an experiment. I would think an experiment is more, how do I say this, more conclusive, I guess, if that makes sense. But sometimes you have to do an observational study. For instance, here's an example. If you want to know, again, in an experiment, some kind of treatment is applied. Or control, I guess. Some kind of treatment is applied, and they're trying to see what effects that has. So for instance, let's say a doctor explores the effect of music on people's temperament. Maybe I think that should have been treatment, but they're trying to see what effect music does to people, right? Well, the music would be a treatment. The music would be the treatment. That's what they're administering, and they're seeing the effects. It's an experiment because they're administering music as a treatment. I guess my guess is that in an experiment, well, we'll get to that. Well, here's another one with a bathroom cleaner. You might buy a bottle of it and clean your bathroom with a new bathroom cleaner, as opposed to buying what you usually buy, or cleaning it the way you usually do. And you might see, well, what effect does it have? Is it better or what? That cleaner you're using is the treatment. That's something new that you're doing. You're using it. That's what we're doing here. Again, they usually do this with testing medicine. They administer some kind of medicine to people, and they'll see what effect does it have. as opposed to this medicine or not taking anything. You know, that's treatment. Okay. Now, speaking of music, you might have heard that people say that classical music supposedly helps people get better grades, helps people study better, I think it is. So people who have listened to classical music, I guess, they would do better on exams or something. But there's really something else going on there, isn't there? I don't think listening to music itself is what's making them do better. What's actually happening is I think they're reducing their anxiety. You know, they're more relaxed. And when you're more relaxed, you're more focused and you can think better, more clearly. In other words, with experiments, you can have what's called confounding. That's when you have two or more potential variables that could have caused the outcome. It's not possible to determine which actually caused it. Again, with the exam one, right? Well, this one's a little bit different. But if they were listening to classical music before an exam, or calming music, I should say, right? What really helped them do better on the exam? Was it the music or the fact that they're more relaxed? You know, there's other variables floating around. That's what confounding is. That can happen when you're in an experiment, so to say. When you're giving one, that is. You know, something that can happen that you really don't like. With this exam thing, as you can see, you know, they might have students listening to classical music they take an exam, then they listen to classical music, and then they take another exam that's similar. And let's say they do very well in the second exam. I mean, can you say it was the music that did it? I don't think so. It's possible, but there's other things you have to account for. Maybe, again, like I said before, it could be how relaxed they were. Or also, after the first exam, they might have realized, oh, wait, this is the right formula you use. Or this is what happens. You know, they might have remembered the material better. In other words, they could have been more warmed up and more ready for the second exam. In other words, we don't know what really made it so that they did better on their second exam. They're confounded. Or here's another one that the book had, another example. People take a diet pill, let's say they decide to lose weight, a group of people. Now, after being on that diet pill for a month, those people lost 10 pounds on average. So some lost more, some lost less. But a possible confounding variable, as I have here, well, maybe they exercised and changed their diet. That can have an effect. So it may not have been the pill. I mean, maybe the pill helped, but it really might have been the exercise and dieting. That could have been what did it. You know, so in other words, you have to be careful. Confounding can really make a lot of trouble. So, okay, well, with that said, is there anything we can do about it? Well, yeah, we can deal with it. I mean, that is, we can help eliminate it. That's where this notion of a control group comes into play. With a control group, basically an experiment as I have here, you're going to get two groups. You're going to form two groups. One group gets the treatment. The other one, called the control group, does not get that treatment. The treatment group gets the treatment, hence the name. So that's what happens. So in that diet pill example, you would have a group of people that don't use the diet pill. Another group does. And besides, whether they get the treatment or not, the groups are similar or as identical as possible. You know, as we said before, there's always going to be some kind of variability. I think we said that. Anyway, that's what the idea of a control group is. That can help. Basically, you're keeping everything else identical as possible except the treatment, excuse me. So with that diet pill example, you would monitor both groups, exercise and diet, and make sure make sure that they're the same. If they do change, well, you would make sure that they're the same, in other words. The only difference would be the diet pill. Because then you can isolate if the diet pill really did anything. That's why they have a control group. Or like with the example, you could have one group that does not listen to the exam. And then you can see, did the music really have any effect? I know at medicine they do this. They might give, a new pill they're trying or a new medicine. They might give it to one group, the treatment group. The control group, would not get the new medicine. They may get nothing, although that could be problematic also. As we'll see here. They want to determine, did treatment really have the effect? They don't want confounding to occur. Now with control groups, though, you can have this problem called the placebo effect. In other words, if you don't give the control group anything, you can run into what's called the placebo effect. That's where someone basically reports that the treatment worked, but in reality, they didn't get the treatment. A better definition is what I have here from the textbook. I also got this from a website, verywellmind.com. Basically, they report the benefits, even though they got a fake treatment. They got what's called the placebo. That's what the placebo effect is. They experienced a benefit, even though what they got was a fake lookalike treatment. They didn't get the actual treatment, but they still reported that what they got worked. It's kind of like with that headache with a diet pill, let's say. Assuming that you have the treatment group and control group, and the diet and exercise did not change. It was the same among both groups. Someone that got a sugar pill or a fake pill, let's say, they may report losing weight. The diet pill really worked, but they didn't get the diet pill. That could be called the placebo effect. Or for instance, if a company is trying out a new headache medicine, someone might receive a sugar pill instead and report that, oh yeah, that medicine worked. But in reality, they didn't get the medicine. They got a sugar pill, a placebo effect. All right, that's what happens. That's why also in certain medicine experiments, they'll use sugar pills or they'll use like a fake saline injection to make it look like a real medicine. In other words, they'll do something like this. They'll use what's called the placebo. It looks like the real treatment. So to compensate for the placebo effect, they'll use a dummy treatment that's called the placebo. And what they'll do is they'll actually make it so the experiment is a placebo-controlled experiment. In this experiment where they use a placebo, then you have what's called the placebo-controlled experiment. My guess is what happens, they don't tell the person if they're getting the placebo or the real treatment. In this example I have here, let's say they want to know what effect does alcohol have on memory. The treatment group might get the actual alcohol, but the control group might get a placebo like non-alcoholic beer. I think they both taste the same and they both look alike, so they can't tell by looking at it or tasting it, I guess, if it's really alcohol or not. They might do that. So this would be a placebo-controlled experiment. Or like with the diet pills, like I said, one group might get a fake pill, like maybe a sugar pill or something. The other group might get the actual diet pill. And other than that, both groups are the same. So in this alcohol example, both groups are the same except who gets the real alcohol, who gets the non-alcoholic beer. I should say this also. Are there any close to 15